Hello, this video is for Trig section 7.0. So a strong theme of this chapter is formulas. So we're going to have all kinds of crazy formulas in this one, so make sure you're kind of preparing a note card as you go. So some of the formulas we start with here are for the arc length of a circle. So what that means is just this blue curvy part right here. So the crust of the pizza. Now, if you remember back from our formula of circle days in geometry, we found that the whole circumference of the circle was 2 pi r. So what we did is we just took a little slice of that based on how big of a slice our pizza was. And that, of course, is determined by the angle here. So you'll find that this right here comes from our circumference formula, but it's cut off by however big of a slice theta we have. So it is related to our radians. And what happens is that since the radians are in 2 pi, in our unit circle here, that the pi's end up kind of canceling out. But because of that, this formula is specifically designed for radians. So just a heads up, every once in a while they'll throw a problem at you with degrees, and it's not set up for degrees. So you have to go and change your degree angle into radians because it makes it nice and pretty where the pi's canceled out and all of this kind of stuff. So let's try it out here. So in our first one, they give us an angle here in radians, and then of course our radius, I know two similar words here, of 5 inches. Now, one heads up too, if they did not say this word right here, I would still have known that those were radians because it did not have the degree symbol. So if they ever give you an angle measure without any sort of indication of which way it is, look for this right here, because every time it's in degrees, they will always use the degree symbol. So if there's no degree symbol, that implies that it's in radians, even if they don't use that word radians. So they expect you to know that. So if they just said that theta was 4 and nothing else, that means it's 4 radians. So I'm going to try it out here. My arc length denoted by the letter S, because of course of all the letter S's in arc length. And then we take the radius 5 inches from the center to the outside times the angle theta of 4 inches. 5 times 4, of course, is 20, which is our final answer. Isn't that nice and easy? So as long as you know the formula, these are relatively easy problems. Now, like I said, if they give you that angle in degrees, we can't just go 240 times 4 because it's not set up for degrees. So the first thing we have to do is switch it over. So I know that if I have degrees, then I want the degrees to cancel. So I know that 180 degrees is the same as pi radians. So I work that out in my calculator. I see that it does reduce to, lost my place there, okay, 4 pi thirds. Okay, 4 pi thirds is now my theta, my angle in radians. And now I can use my formula just like I did on the red one, where the arc length S is the angle times the radius. Radius this time was 4. The angle was 4 pi thirds. And now we know that multiplication is commutative, so if I had written 4 pi thirds first and then the 4, I would have gotten the same answer. So my final answer is 16 pi thirds, or as a decimal using 3.14159 ... for the pi, it would be approximately 16.7552. So just be careful, watch those instructions on whether they want it in exact form, meaning like this with a pi symbol, or in decimals, and then watch for how many places they want you to round to. All right, so the area formula is also coming from a formula we already know. If you remember, the area of a full circle was pi r squared. So it's that same idea. Here's our r squared. And again, the pi kind of works itself out when you're dealing with radians. So again, this formula here is made specifically for radians, only works for radians. So if you have a degree, like we will use on our second example, just like the blue here, we're going to have to first change degrees to radians to get to use our nice pretty formula. There is another formula for degrees, but it's not nearly as pretty. It's much easier just to switch over and use the pretty formula. So right here, let's try it out. This one again is in radians. I know that because there's no degree symbol. So even if we don't see a pi in there, I know it's radians because there's no degree symbol. So let's try it out. The area of this sector is 1/2. That's just part of the formula here. Okay. The angle pi 6 theta times r squared. Now be careful, even though it is still commutative like the last one, I have to make sure to square the r, not the theta. Okay, so if I accidentally squared pi 6, that would obviously give me a different answer. So this one, let's write exact form first, would give me, let's place 1 second, there it is, 4 pi thirds, because of the ways all these fractions here cancel. 4 squared is 16, but then this would cancel to 8, and this would reduce to 4 pi thirds. Okay, which, very similar up there, would give us an approximate decimal answer of 4.1888. So just watch those instructions if it wants it in exact or decimal form. So just slightly more complicated. Again, just be careful that you square the correct thing. That's the most common mistake I see. You just get in a hurry and square the theta because you're used to swapping these right here. Okay, so I'm going to do it in blue again just so we know that those were the degree ones. Again, I know it's degrees because it has the degree symbol. So I'm going to first take my time and switch 75 degrees into radians by canceling those degrees. 180 degrees on the bottom, cancel the degrees on the top, and switch it into radians. So that one will reduce to 5 pi twelfths. Okay, you don't necessarily have to reduce, but it's easy to do with your TI calculator. You would just type in 75 divided by 180, leave the pi symbol off, and then do your math, enter, to get the reduced fraction. So just doing that gets the angle in radians as 5 pi twelfths. Now we're going to plug it into the area formula, which again has the 1/2. That 1/2 is coming from the fact that our formula was pi r squared, and we have the 2 pi r, okay, coming in from our radians. So it just ends up as that 1/2 there. Theta, we decided in radians, was 5 pi twelfths. And then the radius this time was 7. Remember, like I said, just to be careful to square the radius, not the angle. So first off, in exact form, again, the exact form is easy to get. Just type in all of the numbers and not the pi. So I would type in 1/2 times 5 twelfths times 7 squared, and then do my math, enter, to get the number part, the fraction part of 245 24ths. And then I would just know that there's a pi next to that. Okay, that one's not very pretty. If I got him in decimal form, that would give me 32.0704. Got a little sloppy there. That is 245 pi over 24, and then the decimal is 32.0704. All right, now that we are pros with these formulas, let's take it backwards. So this time they gave us the angle, they gave us in degrees, of course, they have to switch that over. So you may already know this one off the top of your head. 45 degrees is one of our kind of common ones, which if you switch that over, gives us pi fourths. So once we know the angle in radians, which is always what we need, I can use my formulas and work my way backwards. Because this one, instead of asking me to find the arc length and area, it gave me the area. So I know that the area is always equal to 1/2 theta r squared. So instead of finding the area, 9/8 pi is the area. 9/8 pi is equal to 1/2 theta r squared. I know my theta is pi fourths, but I don't know the r squared. So I knew the area, 9/8 pi, 1/2 is part of the formula. Theta I found in radians, remember I always needed radians, was pi fourths, and this helped me to find the variable, the one I don't know, of r squared. All right, so let's work this out. So the first thing, if I just kind of cleaned this up, I would get that the 9/8 pi, or 9 pi eighths, is equal to pi eighths, because 2 times 4 is 8, r squared. So if I divided both sides by pi and multiplied both sides by 8, almost all my problems would go away. So let's write that out so you can see how it works. So I'm going to multiply by the 8 because that would make those 8's on the bottom cancel. Okay, so this is me multiplying both sides by 8. Okay, that would take care of that, but I also have a pi that I need to cancel because I'm trying to solve it for r squared. I'm trying to get him by himself, so I need this pi to cancel. It's on the top, so I would cancel him by putting him on the bottom. So all I did right here is I took both sides of my cleaned up equation right here and multiplied by 8 over pi. Let me fix this right here. There we go. Okay, so that of course cancels down and gives me just the 9 equals r squared. So remember, if I square root both sides, technically there's a plus or minus, but of course we're dealing with, real variable, tangible things, geometry. So I wouldn't have a radius of -3. That'd be weird. So the final answer will just be +3. Sorry, I just wrote plus or minus 3. But I'm only going to answer the realistic +3 because we're dealing with a length here, not just a general, mysterious variable number. All right, well, now that I know the radius, life is much easier because I already knew the angle, the theta. Now I know the radius. So it says using our newfound knowledge, let's go back to our traditional arc length formula and find that, which means we just need to multiply. Now remember, I do need to multiply the radian measure, not the degree. This one's the easier one, not squared and all of that stuff, so it would just be 3 pi fourths. Okay, 3 pi fourths, and just in case if you needed it as a decimal, that gives you 2.3562-ish. Okay. Too bad. Like I said, it's just a matter of having those formulas handy and remembering to keep them in radians. That's the biggest thing. I see people make a mistake just getting in a hurry, and then, like I said, squaring the wrong thing. Watch for those two things. So let's step it up a notch and do word problems, everyone's favorite. Remember the first step, don't panic. These are always the easiest ones. So the minute hand of a clock, how far does the tip of the minute hand travel? So which formula are we using? If it's the minute hand going around the outside, that must be the crust of the pizza, the arc length. So it says it's 2.2 centimeters long. The clock hand always comes from the center, of course. So that looks like a radius. Okay, so they just gave us a radius in a kind of sneaky way, dealing with real life things. And then it also gave us the angle in a weird way. It said 10 minutes. So 10 minutes is how far that the minute hand traveled. It doesn't really matter what time it was. If it was from 3 to 3:10 or 6 to 6:10, it doesn't matter. It's always going to move the same amount in 10 minutes. So in 10 minutes, okay, it's moving around. And we know that if it went all the way around the clock, that would have been 1 hour, which is 60 minutes. So 10 minutes out of that total 60 minutes, okay, would be a fraction of the clock, a fraction of the circle, and we want it in radians, so we want 10 out of 60th of the full 2 pi radians. Okay, so we wanted this angle, the angle that happened in 10 out of 60 full minutes of the angle in radians, 2 pi. So this is going to be our theta. Okay, now that we have our information, let's put our pieces together. So the arc length, the tip of the hand traveling around the outside, would be the angle, which we don't even have to have it figured separately. We can just put it all in here and work itself out. Sorry, my 10 looks like a 6. 10, there we go, times 2 pi. That is my angle. And then the radius, of course, was just 2.2. So again, if I use my calculator, it works itself out if I just type in the number part. So just type in 10 divided by 60 times 2 times 2.2. Then do your math, enter, enter, and you should get the fraction of 11/15. Since there was a pi here, that would be 11/15 pi. But I'm pretty sure I remember this one wanted the final answer in decimal form, which would be 2.3038. And then just watch their rounding instructions for how many decimal places to use. Okay, I always like 4 just because that's my favorite. All right, lawn sprinkler. So here it is. It's set to rotate through 90 degrees of the yard. That's a nice pretty one. So it comes along the fence or whatever here, and then it goes sprinkle, 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 all the way through this area here. But of course, it's dealing with the limited spray, so that would form this kind of quarter circle here. Sprinkle, sprinkle. All right, so we know the angle, of course, is 90 degrees. Now this one you might know off the top of your head, but just in case you didn't or they gave you a weird one, remember that we could always change it by doing the pi over 180. I do the pi over 180, not 180 over pi, because I needed those degrees to cancel. And this gives you the hopefully familiar angle of pi halves. Okay, so I've got my theta going on, got that figured out. Always need it in radians. And it says it projects out 50 feet. Well, that looks a whole lot like a radius. Now we have all of our information. So what is the area of the yard sprinkled? We've got that formula. It's right on the previous slide. We are all set. Again, just be careful that you don't accidentally square the theta. Square the radius. It'll seem kind of big just compared to our other numbers, but that's okay because this is an area of yard. Now again, let's just get it an exact first because that's always a good thing to have. And that would give you 625 pi. Again, that's just typing in 1/2 times 1/2 times 50 squared. Or as a decimal, 625 pi gives you 1963.4954. Now it might seem like it's the wrong answer because it's so big, so much bigger than our last answers. But if you think about the context, this was out 50 feet from the yard, so you would expect if it did a square, 50 times 50 is what? I don't know. What's 50 times 50? 2,500. And so it's a little bit less than that because of course it didn't reach all the way to the end of the square. So this seems like a reasonable answer. So just kind of use your reasoning skills there. Make sure it does make sense. All right, last one. Now this one's a sneaky one. Okay, there's the trick in here. So really watch this one. Don't stop the video early. Now, it's got a wiper blade that's 4 inches long. Okay, hopefully all of you have seen windshield wipers. It goes through an angle of 60 degrees. That doesn't sound like very good wipers. I'm pretty sure you've got an area of your window that's in danger. Okay, but if that was 60 degrees, here's the sneaky part. So let me take that 60 off real quick. The rubber part of the blade covers only which was